second focus and second directrix. Now basically what this means, in an ellipse we are having two focus and two directrix. Okay, the line in the blue is the directrix, as in a parabola we were having only one focus and one directrix. Okay, same in the ellipse we are having two focus and two directrix. Okay, so let me explain you now. Since this ellipse, okay, since the ellipse is symmetric to y axis, this ellipse, this is also symmetric to y axis. Now if on the x axis the points S dash and Z dash are taken, already I have marked it, S dash, sorry, not Z, S dash and Z dash, and these points are on the x axis, are taken, then S dash is also a focus of an ellipse, and L dash M dash and L dash M dash, this point L dash M dash means this straight line, and L dash M dash the line passing through Z dash, this point line is passing through Z dash and perpendicular to ZC Z dash, Z point of the first directrix, then C be the center and Z dash. Okay, perpendicular to ZC Z dash such that now what we are having, distance of C S dash is equal to distance of C S is equal to AE, and we are having distance of CZ dash is equal to distance of CZ is equal to A upon E. Then L dash M dash will be the corresponding directrix of an, is it clear? Now this is what, this was the equation of the directrix, we have already done it. Okay, so distance between CS dash and CS is equal to AE, and CZ dash and CZ is equal to A upon E. Okay, so CS dash, CS dash and CS, and from C to S. Okay, so now what this shows, now this shows that the ellipse has two foci that are plus minus AE comma 0 and two directrix that are x is equal to plus minus A upon E. I have already mentioned x is equal to negative of AE, x is equal to positive of AE. For coordinates of the focus AE comma 0 and negative of AE comma 0. Is it clear? So that's why we are saying second focus and second directrix.